One of the things that we'll encounter as we start talking more about physical properties of solutions is a Van Hoff factor. And we have to use a Van Hoff factor whenever we're dealing with ionic compounds that will dissociate. So ionic compounds rarely dissociate completely, but we still most of the time assume that they do. And I'm going to show you what that means in just a second. So we have this factor that we call the Van Hoff factor, which is a lowercase I. And the Van Hoff factor tells you the moles of particles in solution over the moles of the solute dissolved. So let me show you how we can look at a Van Hoff factor. So for this example down here, let's assume complete dissociation. So we're going to assume that the ionic compound is not staying together. So for instance, sodium chloride. Sodium chloride would dissociate into sodium ions and chloride ions. So if we assume complete dissociation, this one solute particle could go on to form two ions. So we would say it has a Van Hoff factor of 2. So I equals 2. Now if you were to have calcium chloride and we assumed complete dissociation, then it would dissociate into calcium 2 plus ions, but then it would dissociate into 2 chloride ions. So then we would say that it has a Van Hoff factor of 3. So what happens if you have something like C6H12O6? Let's say we have glucose. And then we say glucose is a covalent molecule and it does not dissociate. So if something doesn't dissociate, we would assume that I equals 1. Now if there's ever a problem where we don't want I to be an integer value and we don't want you to figure it out, we will give you the I value if it's not complete dissociation or if it doesn't dissociate. And that's all the Van Hoff factor is.